Good morning, everyone. My name is Akash Dharmarajan, and this presentation details my research on AI-driven energy management, focusing on optimizing energy supply and demand for a sustainable future. As the energy landscape is rapidly changing, presenting significant challenges for energy providers and consumers, my research proposes a solution using AI to bridge this gap. This presentation will cover the key objectives, literature review, related works, design flow diagram, implementation, limitation and mitigation, expected outcomes, and conclusion and future research direction. So this agenda will help you to go through the other presentations. The core objective is to optimize energy systems. So we aim to develop an AI framework for energy management, optimize the energy supply and demand, and improve customer engagement through a responsive feedback system. So some of the benefits this approach promises like reducing operational cost, promote sustainable practice, and enhance energy reliability and stability. As you can see in this graph, the majority of household energy consumption is dedicated to space heating. So our system aims mainly to intelligently manage these demands. So space heating is nothing but the usage of air coolers or HVAC systems in a household places. So if that energy consumption is reduced, so we'll have an optimized energy system itself. So introduction. There is a rising global energy demand fueled by population growth and economic development. Poses significant environmental challenges. So traditional energy sources are unsustainable. The need for cleaner and more sustainable energy source is urgent. Here, this map highlights the global variation in energy transition readiness. So our work aims to contribute to a more efficient and a sustainable future. Next is the literature review. So our research builds upon existing work in these fields. So if you could see certain papers like automatic scheduling of household appliances. So this is how we could schedule the space heating. And this could optimize the power consumption. Demand side management. So energy demand can be managed using algorithms. Forecasting household energy consumption. So we could develop and validate what all the models are being used to forecast energy consumption and how they are performing better. And analysis of effectiveness of utilizing power monitoring device to reduce electrical energy consumption. So home management systems, how they are being used and how we can use it for customer engagement. And that could be energy optimizer. And Gen AI chatbots. So how we can use Gen AI chatbots to have a customer engagement and facilitate an energy saving policies. So all these papers are helping for our research. Next is the design flow diagram. Here we have like 4 steps. First is the data acquisition process, where we collect real-time data, let's say from smart meters and weather-related data and some grid status. So like we'll get the input source about it. Next is data analysis. We do exploratory analysis, analyze the trends and patterns of energy consumption, do some plotting graphs, all these for it. And then we go on to the prescriptive analytics. So here, prescriptive analytics is the combination of predictive, and then after prediction, we'll be defining some action items, actionable recommendation for this energy supply and demand. So that prescriptive analytics is done. And finally, the consumer feedback or the customer feedback. So since we are providing a personalized energy consumption apps, so we could provide consumer feedbacks and get and get better feedback from the customer, and then develop the energy apps more useful for energy optimization. Next is the predictor model. So here in this research, we used energy forecasting models. So we have compared like traditional models like regressions and neural networks or deep learning models also when we are having like humongous data of energy patterns. So what we could see is the traditional models offer better scalability, but LSTM excels in accuracy, delivering 90% forecast accuracy. So next slide, if you see, here we have the metrics also showcasing the benchmark. So we use linear regression, ARIMA is another time series model, and then LSTM. So if you could see, LSTM is having like better accuracy and better output. So with this model, with this AI technique, we could accurately predict our energy demands. And these are the energy and management applications. So we have like two major things. One is showing the consumption energy consumption and how the prediction has been done over it. So here, if you see on the left side, we have energy readings in blue, and orange ones will be showing the predicted consumption, which has been trained and made through LSTM. So here it is, we have like 2018 to 2020 data, and with that we have been doing it. And this is the expected energy apps we are making. So for a household, let's say we could monitor it, and we can have like per day, like how much units of energy is being consumed, and what all those appliances activity, and what all the weekly trends, how much watts we have been consuming. All these will be given to the customer as a feedback, so that they will be aware of it and use it accordingly. So this is the energy feedback model which we have been using. So it is actually a cycle of feedback, perception, interpretation, motivation, and ability. So based on these, we have been using to analyze the energy consumer behaviors and then calculate the energy consumed. So there are like two types of feedbacks. One is indirect and direct. Indirect is based on the history data. Like we have a standard billing like monthly, bi-weekly, or enhanced billing with info and advice on household specific, or enhanced feedback like web-based energy audits, daily or weekly feedback. And direct feedback is like real-time feedback. So we can have like smart plugs or any appliances disaggregations so that we can control it whenever there is energy hike over there. There are certain limitation and mitigation. So for this research, the data granularity is one of the major limitation, and external market fluctuation. So external, like we increase the forecast error whenever the new data has been updated. So it is better to utilize real-time data for having a better scalability and generalizing to other regions. So how our model will be adaptable to any system. So how we could leverage our model to already available energy management system. So that one is another limitation. So we could mitigate by adapting those models by integrating certain software or upgrading those tools, something like that. There are challenges as well. So some of the major challenges of this energy project is like we have fluctuating supplies. So since we use renewable energy source and non-renewable energy source, we may not have like a proper supply, so it will be fluctuating. And consumer demand, if consumer energy demand is like unpredictable, then we will have like we don't have a proper engagement, so that we cannot have a like proper policy to provide them to have a consumable like conservative environment. And inefficient management, like traditional energy management system rely on manual process, so those can be leading to inefficiency. So these inability can be changed on time. So expected outcome. This is actually from our current project in our company we have done. So we are able to get like 5% energy imbalance reduction with integrating AI with the energy management system, and $1 million approximately as a savings for it. And 80% of the customer engagement has been helping to making it more sustainable. So final conclusion is the AI roles, consumer engagement, and a sustainable future. So these are the final conclusion for this sustainable future with AI. So AI plays a transformative role in bridging the gap between energy supply and demand. Our AI framework promotes sustainable energy practices, actively engages consumers, and paves the way for more sustainable energy. Finally, the future researches we will focus on exploring advanced AI algorithms, developing strategies for long-term consumer engagement, and ensuring interoperability with existing energy infrastructure. Thank you.